so much. And now I think we can move on to Avishek. So I'll give a little background on Avishek. Avishek, in his current life, works as a senior data scientist at Intuit. So, TurboTax, Mint. So he's keeping track of everyone's taxes and transactions. So he's got a lot of good financial advice, I'm sure. But in a previous life, Avishek and I were fellows together in DSSG in 2016, where he worked on predicting which pipes were about to burst. I mean, he'll show that in a much more friendly way than I have. But I find the way Avishek talks about data and the way he thinks about data, I learned a lot. We used to sit across from each other, and I'd just turn around and ask him for help. He taught me about how to zip things in Python, and I still use that every day and think about Avishek. So beyond this quite sentimental introduction, I'll just turn it over to Avishek, and he'll walk us through what he plans to go over. And this is going to be a bit more of a technical tutorial. So if you've got questions, pop them in the Q&A. And also Avishek will make all of this stuff available on GitHub, and we'll send out the links after the talk.
Thank you for having me. So like Harim said, I work at Intuit now. So I was a fellow in 2016, and then I stayed on at the Center for Data Science and Public Policy for 3 years. And then I left and moved to Southern California and live in San Diego now. And in the age of COVID, I work in my garage because no one bugs me when I'm in my garage. So that's why you can see my car in my garage, my messy garage behind me. So just like Paul said, exploratory data analysis is very important. And although no one will tell you, I explored my data so hard today, it's not, they're not going to brag about it, but it's extremely important to understand what's in your data, to understand the domain, and also to understand how to sort of make an impact. So with that, I think we're going to do a quick 20-ish minute crash course, and then I'll hand it over to Andrea. So why do you do exploratory data analysis? So like Paul says, data doesn't lie, but at some level, all data is wrong. And I forget who said this to me, but I remember shouting this to me. So this was very wise, and I think the person was very annoyed the day they said this to me. And so this is a very buzzwordy way to say that all data has some sort of limitations depending on your use case. And that can mean, what is the resolution of your data? Do you have, say, resolution based on, say, people? Is there anonymization of your data? Have certain variables been omitted? And when working with your partner, they will have an idea of what their data is, but you won't actually know until you actually start exploring it. Secondly, there are always biases in your data. There are response biases. So if you're collecting lots of survey data, certain types of people will respond more than others. So an example is only about 1% of all the editors on Wikipedia write half of Wikipedia. If you have data from, say, 311 complaints, only certain types of people complain about on 311, so you can have biases there. In Twitter, you have things like age bias. There's also things like social desirability bias. So if, say, people have surveys and they tell you what their salary are, in certain contexts, usually they'll inflate their salaries. But say you're applying for social services, and those are for lower income people, then you see that you'll have a bias on the other end where people try to deflate their salaries. So you should keep that in mind. And say, like Kareem mentioned, I work in TurboTax. So if I take your income from, say, your W-2, then that's generally something I will trust. And then there's also selection bias, and that's, well, how did I collect my data? Are there any groups that I may have neglected? And are these groups that I neglected the people that I'm actually wanting to impact? And then there can be missingness in data. It's always important to understand why. So if I have a new data set and I don't see any missingness, what I'll initially suspect is that it's been curated because it's sort of like missingness is a part of life. Now, you have to understand why data is missing. So, is it that, well, I prioritize saving someone's life, so maybe I just put down what I thought was essential? Or maybe missingness is predictive of something. So, say in healthcare, when you fill out healthcare forms, if you don't have an emergency contact, social workers look at that, and what they use that as a measure of things like social vulnerability. And sometimes this is an indicator of people that are trying to hide their healthcare status, or this happens a lot for people who were recently released from prison. So you can see there your missingness is actually predictive of something. And then seems to always be true of any projects we've done at DSSG. The data was not collected for your explicit purpose. So it was probably curated for a different reason. So a lot of times the data is collected for things like compliance or accounting. And it's important to understand that what and sort of how it was curated. And then lastly, and I would say most importantly, as a data scientist, you need to develop domain expertise in the problem you're trying to solve in order to solve it. So when you're looking at the data, you should work with a domain expert to understand sort of how the data was generated, what limitations of the data there are, and sort of any weird idiosyncrasies of the data. And you should always remember that you're in a partnership. And so part of the way you develop that partnership is by finding insights into the data and sharing that with your partner. And it's possible that they've never actually looked at the data the way you are before. And then I would also say, on a sort of meta level, the domain expert you're working with should hopefully be your champion within that organization. So the more tools you can give them to advocate for you and your work, the easier it is for that. So feel free if you want to jump in, anyone, about anything else I might have missed. Okay. So that's the why. So then there's the how. So then there's a question, well, how do you do exploratory data analysis? What do you look for? So everything happens somewhere and at some time. So you want to understand how your data trends over time, and you understand how it trends over space. So you want to see if your data is shifting over time, and you want to see if there's any sort of spatial biases in your data. So like Kareem mentioned, in the Syracuse project, we were predicting what pipes burst, but what we were doing is we were trying to predict which city blocks would have water main breaks so that the city could assess which blocks they could prioritize to replace. And so there were a lot of spatial trends based on things like traffic and population. So then when you have variables, you want to plot summary statistics of your variables to understand where they sit. And there's a lot of good resources on this, but things like your mean, your median, your standard deviation to capture your variability. And then you also want to understand correlations between your variables, particularly sort of what you're predicting and any features you have. And then you also want to understand crosstabs between groups. So if you're doing machine learning, you're going to be predicting something. So in the case of the Syracuse project, we are predicting which water main breaks which city blocks would have water main breaks. So I would say before you do machine learning and try to do the most esoteric deep learning you can think of, you could actually try to find differences in classes using crosstabs and to understand how your different groups are different based on that data.
Abhishek, if I can jump in and just mention one thing here. I think, yeah, the plotting summary statistics and kind of understanding distributions of all the different variables is really important. And this is one part where there's usually a lot of dialogue between you and a project partner, right? So commonly, what we would do is come up with a lot of these summary stats or plots of different variables at the beginning and show them back to a project partner, right? And say, like, does this look right? Because a lot of times, even when you think you understand what a certain field is, they'll look at it and say, oh no, this couldn't possibly have a value of 1,000 or 300,000 or something. So I think it's really important to emphasize there that it's not just you doing this analysis alone, but sort of the back and forth with the partners is really important there too.
Right, exactly. And I would say, um, giving your partners these insights are how you form a partnership and how you sort of get them excited about what you're doing and how you can understand sort of how big the opportunity is of what you're doing. And then you want to understand, say, how rapidly do distributions change over time? Are there seasonal effects, exogenous shocks? COVID-19 has changed the way we live life, how we spend money, changed the tax season. So the American tax season ended yesterday. So I'm very happy about that. And it also can say change your label. The thing you're predicting can change over time. So an example could be in recidivism. Every few years, what the rules for recidivism change. And so then that means that what you're predicting will change over time. And it's important to understand why, because that means what is predicted will change over time. And then lastly, you need to understand why your data is missing. Is it missing because someone isn't filling something out? Is the missingness actually predictive of something? Or is your data not indicative of your population as a whole that you actually want to intervene on? So maybe you're actually neglecting a population that you really want to affect. And you should also understand outliers in your data and why they are outliers.
One more thing just to add, so jump in really quickly, one more thing with the missing data. I think another reason why it's really helpful to understand missingness and what leads to that is then it helps you understand what you might replace missing values with or how you would treat them. So like you said, if it's predictive of something, then you might include an indicator for some value being missing. But also if you can understand that, for example, the project with the EPA, when we were trying to predict hazardous waste violations, when you're looking at how many of a certain type of violation a facility has had in the past, well, if it's totally missing, that means that they've just never had any. So it makes sense to put a 0 there if you have a missing value. But sometimes it would make more sense to impute a missing value with an average, a mean, a median, or some other characteristic value, but that really has to be determined by the data generating mechanism.
Right, in that example, you should also understand the distribution of who makes up your data. So say you had something like gender and height, and say height was missing in your data. If you just took an average and say you had majority men in your data, then say 90% of your data, if you imputed using an average, you'd make, say, all the women in your data look like men. Right, so then you would say, well, maybe you want to average based on what women you have in your data and your men. Okay. Sorry, my neighbors are heading to work now, so you can hear a car going. So then there is bias in your data, and you need to understand what bias there are. So your response bias is how what types of people actually respond to surveys. Selection bias, who did you actually collect data for? Maybe certain people are neglected. In questions where people sort of freely respond, there will oftentimes be social desirability bias. So that's things like salary, and then concept drift. So just like Paul was saying, that your data will change over time and you'll have strong temporal effects. You need to understand how your data is changing over time and why. And then also you can have things like omitted variables. So there was one very famous paper once where they were trying to predict who would have to be hospitalized for the flu. And then they found that people that had the flu and a history of asthma were less likely to be hospitalized. But what they were missing is that the people with the flu and asthma had been in the intensive care unit. And so they were less likely to be hospitalized because they were already under medical care. And so that's an example of, say, an omitted variable. But had you not known that, you could have made a bad causal inference that people that have asthma are less likely to be hospitalized for the flu. And then also just understand that there is a pattern in the missingness of your data. So then this is just like tales from the data of projects that I've worked on where these are issues that came up. So in Syracuse, where you want to prevent water main breaks, what we saw when we initially looked into the data is that the newest water mains had the most breaks on them. And this didn't make sense to us. So we went to them and said, this doesn't make any sense. If they're new, they shouldn't be breaking. So it turns out what happened is that the ones that had the most breaks were the ones that they would replace, and they would just overwrite the date that it was installed. So then we had to go to different records to figure out when the water mains were actually installed. But this was a good insight we had that would have hurt our predictive models had we not caught it. Another project was in recidivism prediction, where what you're trying to predict is when someone is released, are they going to come back into the prison? And so we had about 30 years of data, and I remember building a model, and then I found what was actually very predictive of being in the prison is that if you had a negative number of days in prison, because that meant that you're already in the prison. And so that was the most predictive. And what had happened is that for a certain amount of time that I hadn't caught, someone would enter the day you entered and the exit dates, but they were flipped. And so because of that, that's why the model was so predictive for those people, because those people were already still in prison. And so that's something I actually caught when I made the model, but that's something you want to look for kind of sanity checks that way. And then another project was for HIV retention of patients that were HIV positive. So a certain number of patients drop out of HIV care, and this is bad for both them because they can progress with their HIV, and this is bad from a public health point because this makes them able to transmit HIV. So then we had a lot of healthcare data on these people, and then the healthcare data could be wildly inconsistent. So ICD-10 codes are what are used for billing, and they were extremely inconsistent. They were sort of in the realm of what gets billed. And then secondly, you'll see that diagnoses can be all over the place. So
Abhishek, sorry, just to interrupt. For the ICD-10 billing, what did it look like? Because I've seen what like medical claims data looks like, and you'll see, for example, 15 codes. Somebody's going in with like a sore throat, and they get a barrage of tests, and each of those is recorded. So what did that data look like? How did you understand what was going on in somebody's treatment trajectory?
uh, so So one thing is, say, in everyone's first appointment, you do get a code that gives you a diagnosis of
Okay,
HIV, but also there's variability based on the doctor.
got
So
it.
there's like a ICD-10 code for the dementia induced to HIV, and then that could be considered to be HIV, or that could be considered to be like medications. And so one thing you would see is that across a patient's history, they don't get a diagnosis of HIV every time. But that doesn't mean that the doctor doesn't know. It's just not recorded in the billing.
Got it.
Sometimes when they have a follow-up appointment, it's just more about refilling for medications. And then some doctors are super thorough with everything from like pneumonia to testing to like HIV induced pneumonia. So there's wildly inconsistent throughout the data. And if you look at billing codes in general, you'll see weird things. So you would be shocked how many men get a diagnosis of pregnancy um, through billing
So
code.
I think this is really telling of how deeply you had to dig into the data and talk to the partners, because you're not a, water main engineer or a recidivism officer or a doctor, but you can tell me so much about all of those pieces and the process that goes into it.
Right, exactly. And then I could go to the partner and say, well, is this what I use for understanding the patient? And so the doctor would say, no way, I don't use that. This is what I do to understand the history of my patient. Or if I get a new patient, I look at notes to understand notes or their medications to understand the history of their care.
Got it.
So then there's cases, but then we would talk to the social workers, and they said, well, when you look at a patient's data, what do you look for? So one thing that was really important is they said, well, when I look at do they have an emergency contact? And if they don't, then I go to the patient and I ask them why. And so if you don't have an emergency contact and say you're HIV positive, it can mean several things. One thing that's common is a lot of people try to conceal their diagnosis from their loved ones, so they don't want other people to know. Other times it could be that people who were recently incarcerated, they don't necessarily have a social network, so they don't have that many people to rely on. Or it could be sometimes homeless people would come into the clinic, and so they didn't have an emergency contact. So the social worker understood that these were people to look out for and to sort of make sure that they stayed in care. And so this is an example of where you show the partner what data is missing, and they were able to tell us this great insight that's actually very predictive of dropping out of care. So then there are the tools that you would use. So I would say your bread and butter is learn how to work with databases and SQL. So they're both scalable and efficient. There's been 50 years of work of how to make these things scalable and efficient. Um, then there is Python and pandas. So it's not as efficient as a database or SQL, and it can be a bit clunky. So what my kind of sort of modus operandi is to do the majority of the work in, say, databases and SQL, and do the least amount of work in pandas. And then I will illustrate that first in an exciting live demo. Um, and then visualization in Python, you can do things like Matplotlib and Seaborn are the most popular libraries, and there are other exotic libraries. And then if you're an R person, there's ggplot. And then one thing, I used to not be a proponent of, say, proprietary tools, but I do a lot of Tableau now. So it costs money, but it's proprietary, but it's very powerful. And I call this, there's something I call the Tableau effect, where it's like if you show someone like a Tableau dashboard, you will get their attention and they will be like, whoa, this guy means business. And so I have definitely been able to grab people's attentions with very nice Tableau dashboards and being able to affect change that way.
Yeah, you can make things that look so nice so easily. It will make you never ever want to touch Matplotlib again.
Exactly.
I'm so jealous of all of you with your Tableau while I'm here with my Power BI.
Yeah, exactly. So So if you're a student, you can get an educational license for Tableau. So, and then otherwise you have to pay for it. Okay. So with that, I am going to show a live demo. What I'm going to show is um, motor vehicle collisions. So I wanted to just pull some data. I pulled some data from the New York City Open Data Portal, and I wanted to keep this somewhat raw so you get an idea of the kind of explorative process. And so what this is motor vehicle collisions for New York City. And what had the way the data is, I picked this for two reasons. One, there's a spatial component to it and a time component. And two, they actually go into good detail of how they collected the data. And so what happens is if you have an accident where, say, someone is hurt, they have to be taken to the hospital or dies, or you have over $1,000 worth of damage, the officer has to fill out a report for a certain form. And then those forms are then packaged into the data, into what this data is. So then you see from there you understand that there's what the data collection method is. It's an officer filling out a form, likely probably by hand. And secondly, you see that there is obvious bias in the data, that the accident has to lead to, say, $1,000 worth of damage, or there has to be an injury. So then you understand that is a bias. And so that's something you can go back to a partner and say, well, how many accidents of those do those make up? And then you also see just sort of how the data was generated, that it's probably that someone has these forms and it was easy to sort of put on the open data portal. Okay. So the sort of my modus operandi is try to do as much in SQL and then do the limited amount in Python. So let's hope this works. So it worked a few minutes ago. So if we load this data, what it is first we want to understand what it is. So you see you have crash date, time, what borough. There are 5 boroughs of New York City, your zip code, and your location. You have latitude, longitude, streets, and then what contributing factors there were. So how many vehicles were involved in the crash, and the type of vehicles involved in the crash. And then what you see here is you have a collision ID. So I would suspect this is a unique identifier. So first thing I usually check for is how complete is the data, how many nulls are there. So you see that you actually have a lot of nulls in locations. So what borough, zip codes you have, where the streets, and then you have nulls in, say number of persons injured and killed, right? And so this likely means that just someone just wasn't injured or killed. And then you have a collision ID, and there are no nulls here. So this indicates that this is probably a unique identifier. So what I did for this is I loaded it in a SQLite database, and then you can write queries and get insights based on that. But there's all sorts of other tools you can use, like Postgres, that are free, and then there are other proprietary things like Oracle and like things like Redshift. But I would say working with your partner, try to stick to, say, open source tools, because when you hand it over to them, it's that much easier for them to deploy what you created if they don't have to pay for maintaining it. Okay. So we can open a database. I call it New York City Collisions. And then I just edit column names. So what we see here is we have these, they're capitalized and they have spaces. and this can get to be a pain when we're querying. So we can rename our columns so that they are lowercase, and you have the spaces replaced with underscores. So first thing we can see, well, to what dates do we have data for? So we can find the min and max crash date, and we can see that we have about 8 years of data from July to July. Then we can see, well, is our collision ID really unique? And you should always check. Do not ever believe someone's unique identifier is unique, because that has happened to me before. But you do have as many collision IDs as you have rows. But you could have issues that in one project where we're trying to predict childhood-led poisoning, they told us that every child has a unique identifier in the data for a hospital network. And what really happened is that every child has a unique identifier for each clinic in the hospital network, but a lot of children will go to different clinics within that network. So we have to actually spend a lot of time deduplicating those children. Then you can make sanity checks. How many actual boroughs are there? There are 5. Then you can actually then start to say, well, how many crashes are there in each borough over all the years? And then you can visualize this to understand, say, Staten Island has the fewest number of crashes, but you have a lot of crashes where no one actually reports what the borough is. And then you can say, well, how many cases do we have where there's no any location at all? So there's no borough, there's no location. Location is the sort of latitude and longitude, and there's no actual street name. But maybe there's something actually special about these cases. So it could be, well, maybe these cases were the ones that had fatalities. So an officer, or they had significant people injured. So this is something I would actually ask a domain expert to see that, well, maybe the officer prioritized taking care of someone rather than filling out a form. So then you can see there's a very small amount of cases that actually have no location information. Then you can say, well, how many then you can do a sanity check. Most collisions probably have 2 cars when you have a collision. And then as you increase the number of cars, it should actually decrease. And that's what you see here with the number of collisions where there are 3 cars, where there's 4 cars, and where there's 5 cars. You don't see that many 5-car collisions. So there's very few 5-car collisions. Then you can say, well, let me actually look through time, because if I want to take a decision, like Paul says, at a certain time, I want to understand how time affects my problem. So then I can look at years, and I can see, well, how do traffic incidents occur over years? And we can see it's fairly steady for most boroughs. But in, say, Manhattan, they've had a significant decrease in traffic incidents. So I would ask why. Maybe they've actually intervened, and that was actually, it appears to be quite effective. And then you see in 2020, you have fewer incidents. And although we're midway through 2020, it could be that maybe there's an underreporting of the data, then that's why we have a smaller number. So I would go back and figure out why this number is so small. And it could just be that because we're only halfway through the year. Okay. So then this is looking through years. We can also look and see, well, is there a seasonality effect to traffic incidents? So, and then I'll share this so you can look at how to make pretty pictures in Python, because it's took me years to do something that looks nice-ish. You could say, well, let me look at the number of incidents per month. Is there maybe any seasonality? And so what you can see is that there is a sort of seasonality or a cyclicity. And you can see what I think is that, say, early in the year, you start to see a lot of traffic incidents. And then in the summertime, it seems to decrease. And then as you get into the fall and the winter where you have snow, you have an increase of traffic incidents. And so these are insights you can kind of take to the partner and ask them if they're indeed correct. So that was looking through data through time. And then the last one from my plug for Tableau is, say I want to look at data. Can you see this Tableau workbook?
Yeah, we can see your screen.
Okay. So then you want to say, well, are there any spatial biases in my data if I look at data over time? So this is a heat map with the traffic incidents for 2019. So it's 5 boroughs. So I couldn't find the layout that actually gives you the layout of the boroughs, but this is Staten Island, this is Manhattan, this is Bronx, this is Brooklyn, this is Queens. And so you see that most of the incidents actually happen in Manhattan. So this is Central Park South, where there's a lot of businesses. And then this is the financial district of Manhattan, where you see you have a lot of daily activity. So you're actually likely going to have a lot of traffic because you have a lot of activity. And you see that that's where most of the incidents are happening. And you can see that just by sort of plotting this on a map. Okay. And with that, are there any questions?
So definitely, maybe my conclusion is to add to data does not lie, but never take it at face value, right? So it's kind of that whatever you see there is probably wrong, but what's there is there for a reason, and you need to figure out what the reason is. So you're kind of hunting for the underlying effects or causes that it represents. Very cool. Thanks,
Thank you
Abhishek.
so much.